This program is rated PG. It contains themes and scenes which may not be suitable for very young audiences. Parental guidance is advised.
Good morning mga ka-I-Believers! Welcome back to our show. Ito ang I-Bilib. It's me, your girl, again, I-Believer Julian, and nandito ako ngayon para ituro sa inyo ang optical phenomena. Familiar na ba kayo doon? Kung hindi pa, panoorin nyo kami ng aking mga partner para ituro ito sa inyo. Hi guys! Kung hindi nyo pa ako kilala, ako si I-Believer Ju, and sana marami kayong matutunan dito sa report namin. Bye-bye! Huy, ikaw! Makinig ka sa klase, hindi natutulog ka ha? Nako! Direk, ako po. Saan po ako pupwesto po? Play na po ba? Play na po. Sorry.
Hi mga ka-I-Bilib! Ako nga pala si Aliyah at ituturo ko sa inyo ang wave equation. In this lesson, we're going to learn about the wave equation and how it's used to solve a problem. This equation is used to find wavelength. That's what the symbol represents here. It's a Greek letter lambda. We use the speed of wavelength or velocity of the wave and frequency of the wave, and we're talking about wavelength. We're talking about the distance of one cycle, and we can measure from crest to another crest that will be equal to one way of length, or we could also do true to true. Those will also be the same thing. Now we're talking about frequency. We're talking about how many of those wavelengths will pass by a given point in 1 second. So let's try a solving problem. This says that the person shouts in their voice creates a sound wave with frequency of 540 Hz. Their voice travels a distance of 154 meters before it's heard by their friend 0.467 seconds later, and then it asks what's the speed of wavelength and the period of wave. Let's start with the first one. To find the speed of the wave, we can actually just take a look at standard equation to find speed. We're trying to find speed of something. We take how far it traveled, the distance, and divided by the time. We know that this wave traveled 154 meters, and it took to the 0.467 seconds. And so I've just plugged into those numbers, and I find that the speed of this wave, if it's 330 meters per second, and we use the SI units there of the meters per second when we're dealing with the waves. Now I can move on to the wavelength, and I can use the wave equation for this. Now that I know the speed of this wave, I solved for that, and I found it was 330 meters per second. I can just divide that by the frequency which was given to me in the problem up here, 540 Hz, and I'll find a wavelength of 0.8611 meters. And when we're talking about wavelength, that's a length, and so we use the SI unit of meter. So now we'll solve for the period of the wave. And the period of the wave, if we use the symbol T, we were talking about period. The period is the time it takes for the wavelength to pass by a point. And this is going to be the inverse of the frequency. So if we want to find period, we just take 1 divided by the frequency, just like that. So I'll plug the numbers, and I end up with 1.5 times to 10 to the negative 3 seconds. And so period is measured in the SI unit of seconds, because it is a time that is the wave equation and how it used. So that's all. Thank you.
Guys, ito na. Add ko lang na idea dun sa wave theory of light. Pero, ano ba yan? Ba't ba kasi kinukuha mo? Akin na nga kasi yan. Huwag kayo makikinig dun sa isa nating katropa. Pero yung nature of light, nahati daw siya sa dalawang theory. Isang wave theory of light, and then yung isa is yung corpuscular theory na sinabmit ni Newton. Sige na, bye-bye. Ano ba yan? Ba't ba kayo nag-aagawan? Pero nga ako, I-Believer Julian.
'Di ba? Ba't ba kasi kinukuha mo? Akin na nga kasi yan. Huwag kayo makikinig dun sa isa nating katropa. Pero yung nature of light, nahati daw siya sa dalawang theory. Isang wave theory of light, and then yung isa is yung corpuscular theory na sinabmit ni Newton. Sige na, bye-bye. Oh my God! Nakastart na naman. So, sige. Ako na lang magtuturo sa inyo since nag-aaway-away sila.
Kung kanina, in-explain ng ating I-Believer na si Van ang wave equation, ngayon naman tumungo tayo sa nature of light or ang wave theory. Saan nga ba nanggagaling ang ilaw? Nature of light or the propagation of light can be explained by two theories, which means meron dalawang scientists na nagpropose ng kanilang idea na naging theory, and first one is our wave theory of light, and the next one is corpuscular theory of light. Ngayon, tatanungin kita, ano nga ba sa tingin mo ang light? Is it a particle or a wave? So first one, wave theory of light. Light is part of electromagnetic radiation. When we say electromagnetic, it comes from the two words, electric plus magnetic. So, electromagnetic radiation. Radiations which are produced by oscillation of electrically or magnetically charged bodies are called electromagnetic radiations. Ito yung tinatawag nating waves. Meron tayong iba't ibang waves. First one is gamma rays, X-rays, ultraviolet rays, visible light waves, infrared waves, micro radio waves, TV, and radio waves. They are propagated in the form of waves. The waves consist of oscillating electric and magnetic fields perpendicular to each other and also perpendicular to propagation of wave. When we say perpendicular kasi, kumbaga equal siya, di ba? Kung nakakakita kayo ng mga waves, is pantay yung kanyang troughs and yung crest. I-explain ko kung anong pinagkaiba ng dalawang yon. The light waves travel with velocity of 3 by 10 raised to the power of 10 or seconds or 3 by 10 by 8 meters per second, which is the velocity of light. Characteristics of wave motion, tumungo naman tayo dito. Ano nga ba yung mga importanteng characteristics ng wave motion natin? First one is our wavelength. Second one is the frequency. Third is our wave number. 4 is the velocity of waves, and the last one is our amplitude. Corpuscular theory. Today we're going to learn about Newton's theory. Sir Isaac Newton's corpuscular theory was one of the earliest scientific attempts at understanding the nature of light. Even though it was originally set forward by Pierre Gassendi, it was Newton who had later developed and proposed the corpuscular theory of light way back in the 17th century. However, after 100 years of existence, it later gave way to a more popular Huygens wavefront theory that could explain some of the limitations of Newton's corpuscular theory. This theory of light states that the following light consists of corpuscles, which are a stream of discrete tiny light and perfectly elastic particles. Every luminous source like the sun, a lamp, or a candle emits these corpuscles. These corpuscles travel in straight lines in all possible directions. The rate at which these corpuscles travels may differ depending on the medium in which they disperse. The vision of human beings is a consequences of these corpuscles falling on the retina of the eyes. Various colors of light are due to the difference in sizes of these corpuscles. The difference with this, it is the corpuscles perfectly explains the concept of reflection and reflection of light. Corpuscles is just like throwing a perfectly elastic ball that hits the wall, which is the right lane. When this ball hits the wall normally, it bounces back and travels along the same path that it takes during the throw. However, when this ball is thrown at an angle to the wall, it bounces back and away from the wall at an equal angle. With respect to the normal, however, it takes the opposite direction. The angle of incidence of the ball is equal to the angle of reflection. Our reflection of corpuscles of light follow the same rules that reflection of this. In other words, each of the corpuscles behave just like an elastic ball.
This means that when corpuscles hit the surface, normally they travel along the same way back, and when they hit a surface at an angle, they are repelled near the surface and reflected back such that the angle of incidence is equal to the angle of reflection. As according to the Newton, the refraction of light was due to the supposed change in the speed at which they traveled, thereby causing a resultant change in the direction whenever these corpuscles enter from a denser medium to a rarer medium. Although Newton's corpuscles theory of light could successfully explain the reflection of light, his assumption of higher velocity of light in denser medium as compared to the rarer medium has been disproved. He was also unable to validate his supposition that various colors of light are due to the difference in sizes of for the reasons of the corpuscles. This hypothesis we rendered baseless, the biggest limitation of Newton's corpuscle theory of light was that it could not illuminate the phenomena of interference, diffraction, and polarization of light. This is why the theory was later abandoned in favor of Huygens' wave theory of light, which proved that the light travels in the form of waves.
Hi, I-Believer! My name is Frenerim, so let's talk about speed of light. Speed of light in vacuum is 186,282 miles per second. And in theory, nothing can travel faster than light. In miles per hour, light speed is a lot, about 670,619,629 mph. If you could travel at the speed of light, you could go around the Earth 7.5 times in 1 second. So ayun mga ka-I-Believer, ayon sa ating scientista na si Einstein at sa iba pang scientista na mas mabilis ang ilaw kaysa sa tunog dahil ang ilaw ay naglalakbay sa hangin at kalawakan ng 30 milyong bawat segundo.
3 hours later.
Early scientists unable to perceive light's motion, though it must travel instantaneously over time. However, measurement of the motion of these wave-like particles became more and more precise. Electromagnetics is a science which studies the electric and magnetic phenomenon with their engineering application, like cellphone, microwaves, yun may mga may mga radiation dyan, tsaka magnetic, tsaka yung mga electric.
Quantum physics has a mistake of being complicated and hard to understand. In fact, Richard Feynman, who won the Nobel Prize for his work on quantum electrodynamics, said, "If you think you understand quantum physics, you don't really understand quantum physics," which is kind of disheartening for us, because if he didn't understand it, what chance do the rest of us have? Fortunately, this quote is a little misleading. We do in fact understand quantum physics really well. In fact, it is arguably the most successful scientific theory out there, and has let us invent technologies like computers, digital cameras, LED screens, laser, and nuclear power plants. And you don't really want to build a nuclear power plant if you don't really understand. So quantum physics is the part of physics that describes the smallest thing in our universe. Molecules, atoms, subatomic particles, things like that. Things down there don't quite work the same way that we are used to up here. This is fascinating because you and everything around you is made from quantum physics, and so this is really how the whole universe is actually working. I've drawn these protons, neutrons, and electrons as particles, but in quantum mechanics, we really describe everything as waves. By the way, I'm using quantum physics and quantum mechanics interchangeably. They're the same thing, so instead of an electron looking like this, it should look something like this. This is called a wave function, but this wave function isn't a real physical wave like wave on water or a sound wave. A quantum wave is an abstract mathematical description. To get the real world properties like position or momentum of an electron, we have to do mathematical operations on this. Wave function, so for the position, we take the amplitude and square it, and it would look something like this. This gives us a thing called probability distribution, which tells us that you are more likely to find an electron here than here. We actually measure where the electron is. An electron particle pops up somewhere within this area. So with quantum physics, we don't know anything with infinite detail. We can only predict probabilities like this will happen, and it looks like this is a fundamental features of the universe, which was quite a departure from the clockwork, deterministic universe of the classical physics, this kind of thing Newton derived. This wave function model predicts what subatomic particles will do incredibly well. But weirdly, we got no idea if this wave function is literally real or not. No one has ever seen a quantum wave because whenever we measure an electron, all we ever see is a point-like electron particle, so there is like this hidden quantum realm where the waves exist. And then, the world we can see, which is where all the waves have turned into particles. In the world, and the barrier between there is a measurement. We say a measurement collapses the wave function, but we don't actually have any physics to describe how the wave collapses. This is the gap of our knowledge that we have dubbed the measurement problem, and this is the one of the things that Feynman was referring to with his quote. Another confusing thing is how exactly to picture an electron. It seems to be a wave until you measure it, and then it is a particle, so what actually is it? This is known as a particle-wave duality. And here is an example of it in action. The famous double-slit experiment. Imagine spraying a paintball gun at the wall with two openings in it. You'd expect to see two columns of paint go through and hit the wall behind. But if you shrink this all down to the size of an electron, you see something quite different. You can fire one electron at the same time at the slit and they appear on the back wall. But as they build over time, you get a whole pattern of stripes instead of just two bands. This pattern of stripes is called an interference pattern, something you only see with the waves. The idea is that it is an electron wave that goes through both slits at the same time, and then the waves from each slit overlap with each other, and where the waves add together, you have a high probability of the electron popping up at the wall. But there was the wave cancel out, the probability is very low, so actually on the back wall is the highest probability of finding the electron in the middle up of the slits. And then it goes down and up again and down and up again, and this is interference pattern. So when you fire one electron after another, they follow this probability distribution, and this interference pattern starts building up, and that's exactly what we see in experiments.
Hi mga ka-I-Bilibers, experiment time na. So ano nga ba mga materyales na ang kailangan natin para sa experiment na to? Una, ang lapis, at pangalawa ay baso na may lamang tubig. Dito sa experiment na to, makikita natin kung bakit nga ba
Wait. Kailangan kong huminga. Okay. Game.
Bakit nga ba pag nilagay ko tong lapis dito is nagmumukha siyang nakabend or putol. Ayan, tingnan natin. Ayan. Nakita niyo na. So, nagtataka ka rin, 'di ba? Or napapaisip ka kung bakit nga ba nagmumukhang putol yung portion ng lapis pagdating dito. Yung nakikita natin dito na na para siyang bale or nakabend is dahil yung light reaching portion niya is nanggagaling sa ibang direction, kaya nagmumukha siyang putol or mukha siyang nakabend. Ayan. Optical optics is a branch of optics where light is described by rays. Light rays are conceived as geometrical lines originating from sources, extending through media and being revealed by detectors. Their directions account for path along which light flows. So, madaling salita, itong geometric optics, isa siyang subset ng optics concerning siya sa mga concerning of light with macroscopic material. So, ito namang optics is a branch of physics concerning naman siya concerning the interaction of light with matter. Ayan, light ray, beam of light, or yung sinag ng arrow, or light can travel through empty space, air, glass, water, cornea, eyes, eye lens, etc. Each one referred to as a medium. Light rays will travel in a straight line if they remain in the same medium. Ayan, dito sa reflection. The law of reflection states that the angle of reflection equals the angle of incidence, or theta r is equal to theta I. Yun daw yung sabi, yun yung law of reflection na yung theta 1 and theta r is equals the angle of incidence. The angles are measured relative to the perpendicular to the surface at the point where the ray strikes the surface. So dito naman sa pangalawang picture na to, napapansin naman natin na yung light niya, tas nag-reflect siya sa rough na surface. Mapapansin natin na merong madaming parallel rays incident. Pero itong mga nag-reflected na to, meron silang different angles since nagkaroon sila ng different angles kasi yung surface na nag-reflect, yung pinag-reflectan is rough siya. Hindi katulad dito sa unang picture na yung surface niya lang is smooth lang. So another example is when a sheet of paper is illuminated with many parallel incident rays. It can be seen at many different angles because its surface is rough and diffuses the light. Refraction, deflection from a straight path in passing obliquely from one medium such as air into another such as glass. So dito makikita natin sa picture na to na yung incident ray, pag nag-reflect siya sa one medium, ay pwede siyang mag-reflect into another medium. May example dito. Ito, yung isang lalaki, nakatingin siya sa looking at the fish tank as shown. We can see the same fish in two different location because light change direction when it passes from water to air. Nag-iiba yung direction pag yung light nagpasa siya from water to air. Kaya iba yung direction ng mga isda na nakikita natin. Or yung location ng mga isda pala. Magkaibang location ang nakikita natin. In this case, the light can reach the observer by two different paths. And so the fish seems to be in two different places. Ayan. Dahil nga doon, napansin natin na yung fish na yon is magkaiba sila ng places or yung location. This bending of light is called refraction and is responsible for many optical phenomena. So dito naman may mga computation dito at yung hahanapin natin yung index of refraction. Mas maintindihan natin kung paano nga ba mag-compute ng index of refraction or yung speed of light is panoorin natin to.
Light travels at different speeds depending on the medium that it's traveling through. Light travels fastest through a vacuum at 3 times 10 to the 8 meters per second. And that's actually the speed limit of the universe. Nothing can travel faster than light in a vacuum. When light travels through different materials, it slows down depending on the way the material interacts with the light waves. The slowing down of light is referred to as the optical density of the material. The more optically dense the material, the more the light will slow down. We're not going to really focus on the reasons why light slows down, however we will focus on calculating the decrease in speed of light based on the material. So what are we going to learn in this video? First, we will define index of refraction and look at some examples of the indices of refraction of different materials. Second, we'll learn the equation that we can use to calculate how the speed of light will change. Finally, we'll learn how to solve problems involving indices of refraction. So first, what is index of refraction? Index of refraction is a ratio that compares the speed of light in a vacuum to the speed of light in a material. Essentially, the value tells us how many times slower light is going to travel through that material compared to the speed of light in a vacuum. Generally, gases have the lowest indices of refraction. They slow light the least, and solids have the highest indices of refraction, and liquids are kind of in between the solids and gases. Now, we can calculate the speed of light through a material by rearranging the equation for the index of refraction. So it becomes V equals the speed of light over the index of refraction. There are many different tables that list all of these different indices of refraction for different materials. You can find them in your textbook or online. Here are a few common indices of refraction. Let's try solving some problems that you might see in your physics class. Calculate the index of refraction of quartz if the speed of light through quartz is 2.055 times 10 to the 8 meters per second. First, I'll write the equation I need to solve the problem. Notice that in this problem, we are only given one piece of data. That's the speed of light in the material. And that's this variable right here. We want to calculate the index of refraction, that's n. Now, we don't need to be told what the speed of light in a vacuum is because it's a constant. The speed of light in the vacuum is 3 times 10 to the 8 meters per second. So we can plug everything into the equation, and we end up with 3 times 10 to the 8 divided by 2.055 times 10 to the 8, and we end up with 1.46. There are no units for an index of refraction because it's just a ratio. It means light travels 1.46 times slower in quartz than in a vacuum. Here's another problem. Calculate the speed of light as it travels through diamond. Notice that this problem doesn't give us any data at all. Most likely, you'll have a table of common indices of refraction, and that's where you're going to find the index of refraction for diamond. The speed of light in the material is this variable right here, and the speed of light in the vacuum is this variable. So we will need the index of refraction, n. To solve for the speed of light in the material, our equation becomes speed of light over n. We plug in the value for the speed of light, 3 times 10 to the 8, and then we can look in our chart, find the index of refraction for diamond. That's right here, 2.42. We plug that into the equation. When we do the calculation, we end up with 1.24 times 10 to the 8 meters per second. So in this video, we learned how to define index of refraction, and we learned how to calculate it, or calculate the speed.
So, kita naman natin kanina sa pinanood natin kung paano nga ba mag-calculate ng speed of light. And another example is, how long does it take light to travel 394 centimeter in glass? So, ayan, calculate the speed light. Ayan. I-divide mo lang to sila and makukuha mo yung sagot na 1.997 times 10 raised to 8 meters per second. Ayan, makukuha mo yan. So, dito naman sa law of refraction or Snell's law. Para mas lalo nyong maintindihan or malaman kung paano nga ba computein itong yung law of refraction is may video uli ako na hinanda.
The interface between air and water. It's at a 90-degree angle. Now, when a light ray strikes the point of incidence, three things could happen. The light ray can reflect at the boundary, it can refract, or it could be absorbed by the material. This is known as the incident ray. This is the reflected ray. And the one on the bottom is the refracted ray. The angle of incidence is the angle between the incident ray and the normal line. So let's say that's 45 degrees. According to the law of reflection, the angle of incidence is the same as the angle of refraction. So these two angles must be equal to each other. Now my drawing is not precise, so it may not look like they're the same, but they should be the same. Now this angle here is known as the refracted angle. And in order for us to calculate that, we need to use something called Snell's law, also known as the law of refraction. And it's n1 times sine theta 1, which is equal to n2 times sine theta 2. So that's Snell's law. It can help us to calculate the angle of refraction or the index of refraction. The index of refraction for air is approximately 1. For a pure vacuum where there's no molecules in the air, it's exactly 1. The index of refraction for water is 1.33. So with this information, we can calculate the angle of refraction. So n1 we're going to say is 1 and n2 is going to be 1.33. So it's 1 times sine 45, and that's equal to 1.33 times sine theta 2. Sine 45, that's equal to the square root of 2 divided by 2, which as a decimal is 0.7071. If we divide that by 1.33, we'll get that 0.53166 is equal to sine of the second angle. Now, in order to calculate that angle, we need to use the arc sine or the inverse sine function. And that will give us theta 2, which is the angle of refraction. So if you type in an arc sine 0.53166, it'll give you an angle of 32.1 degrees. So that is the angle of refraction. So notice that as the incident ray moves from a material with a low index of refraction to a material with a higher index of refraction, the ray bends closer to the normal line. The angle decreased from 45 to 32.1. Now the reverse is true. If the incident ray traveled from a material with a high index of refraction to a material with a low index of refraction, the angle is going to increase. And so it's going to bend away from the normal line as opposed to toward the normal line.
Total internal reflection is the phenomenon that involves the reflection of all the incident light of the boundary. Dito naman, yung sa total internal reflection, yung mga involved dito is yun nga yung mga reflections na of the boundary. Ayan, kagaya dito sa ayan, yung ray undergoes total internal reflection. Ayan, ito. When theta 1 is greater to theta c, incident ray undergoes total internal reflection at boundary and cannot pass into the material with a lower refraction index. Ito, maximum value of the sine of any angle is 1. Sine theta c is equal to n2 over n1. Total internal reflection occurs at interface only when n2 is less than n1. So dito sinabi na yung total nag-occur daw yung total internal reflection sa interface kapag mas less than ang N2 sa N1. Ito example para sa total internal reflection. Determine the critical angle for both water and diamond with respect to air. So, yung formula niya is sin theta C is equal to N2 over N1. Water is theta C is equal to sin raised to negative 1 N2 over N1. So, isisulat na yung mga value nung N2 and N1. So, ang N2 is yung 1.0003. And N1 is 1.33. So, dinivide dyan, ang naging sagot is 49 degrees. So, yung critical angle ng water is 49 degrees. And dito naman sa diamond is, ang naging sagot ay, ang naging critical angle niya is 24.4 degrees. So, para mas maintindihan pa yung pagsasolve ng critical angle, meron akong video na ipapanood.
Today's lesson, I'm going to teach you guys how to use the critical angle equation. So this is an equation that comes up when we talk about refraction and total internal reflection. So as we take a look at this first example here, it says find the critical angle for light traveling from water into air. There's a couple of things that we know. We know that we're going from water, and they give us the index of refraction for water, and into air. And a couple of things that we know that we're going from water, and they give us the index of refraction for water, and into air. And the thing that we are trying to solve is the critical angle. Okay? So as we said, we know two things. We know that we're traveling from water and into air. So water is our first substance. So N1 is 1.333. And air is our second substance. So N2 becomes 1.0 because air is always 1.0. And what we want to find is theta C. That's our symbol for critical angle. You take a look to your right in green, there's our equation. Sine of theta C equals N2 divided by N1. So at this point, we just have to plug in our values. So we don't know theta C, so sine of theta C is going to equal 1.0 divided by 1.333. We're going to go ahead and do that calculation. So sine of theta C equals 0.75. We have to keep in mind that all we want to solve for is theta C. So we have to get rid of our sine function. And so in order to do that, to get rid of a sine function is to take the inverse sine. So we're going to take the inverse sine, so that's sine to the negative 1 of 0.75. And as long as your calculator is in degrees mode, you're going to end up with the correct answer. So in this case, our correct answer comes out to be 48.5 degrees. That is our critical angle.
Wow! Napakaganda experiment naman ang I-Bilib Katin. Hello mga ka-I-Bilib, ako nga pala si Seri Perata. Ituturo ko sa inyo ngayon ang dispersion of light and scattering of light. May diya ka na ba dito? Kung wala pa, samahan mo ko at ituro ko ito. What is dispersion of light? Yung dispersion daw, phenomena na yung phase velocity wave niya nakadepend sa frequency nito. Minsan yung chromatic dispersion, ginagamit siya sa pang-specified, although na yung term nito ay ginagamit sa field ng optics to describe light and other electromagnetic waves. Yung dispersion pwede siyang may apply sa iba't ibang uri ng motion like acoustic dispersion in sound and seismic waves, gravity waves, and for telecommunication signals. Also transmission lines like coaxial cable or optical fiber. For example, rainbow. Dispersion by a prism. Dahil dyan, nagkakaroon tayo ng rainbow. So, makikita natin ang sun, which is a white light. Pag ang light rays nag-split in sa prism, which is yung triangle, magbabrot siya ng 7 colors na magiging rainbow. And next naman natin, kung paano naman kung dalawang prism ang tinamaan ng isang light rays. So, mag-splitin ulit ang light rays sa loob ng prism at magbabrot ulit ng 7 lights or color and tatama sa second na prism at ang kakalabasan naman niya is white light. Light absorption and transmission. Ano nga bang nangyayari pag may absorption and transmission? So, kung makikita natin dito, may ilaw na nakatutok sa mga gummy bears na iba't iba ang kulay. So, merong nag-a-absorb at meron din nagtatransmit siya. Ano nga bang mangyayari pag ang light ay nag-absorb sa isang bagay o nag-transmit? So, makita natin dito, pag nag-absorb ang ilaw sa isang bagay, nabumula ito ng energy. At pag nag-transmit naman, ay ito yung magkakaroon ng passage.
What is color? In physics, it is the part of the electromagnetic spectrum also called visible spectrum. Objects absorbs wavelength of light and not others. The colors we don't see are the ones it absorbs and the other colors that we do see are those that are reflected back. And that is why we see things in particular color, like the leaf or the grass. The grass appear green by absorbing other colors from the light and only reflect green. In the visible spectrum, the red has the longest wavelength with 700 nanometers, and the violet has the shortest wavelength with only 400 nanometers. At the red end is the infrared region, and the other end is the ultraviolet. Do you know how many colors are there in the universe? It's been estimated that we distinguish between 80 decillion colors. That is 18 followed by 33 zeros. We have thought that red, blue, and yellow are the primary colors. But did you know that those are the primary colors for pigments, which are substances that add colors to materials? The primary colors of light are red, green, and blue. But what happens when you mix all three of those? We get white light. It is Sir Isaac Newton who figured out the combination of wavelengths spread out along the visible spectrum make up white light. So now we know that white isn't a color at all. It is the presence of all the colors of visible light. And he also understood that what we see as black is the absence of
Let's
light.
explore more about color in our everyday world. We brought in this color projector to do just that. Remember, our primary colors of light are red, green, and blue. They are specific wavelengths of light. When we overlap all three of them in equal intensities, we get white light. Where the three primary colors come together, you can see a small triangle of white light.
We see color when light is refracted or bent at an angle. The wavelengths are distributed along the spectrum, creating what we often think as a rainbow. Let's go to color attenuation. What is attenuation? The attenuation of light or color refers to the reduction in its intensity as it travels through a medium due to absorption or scattering of photons. As we have discussed earlier, we all know that objects appear in particular color because of the spectrum with different colors, which is either absorbed or reflected by the object. But why objects appear the color they do? It depends on two things: the wavelength of light that are hitting it and the properties of the object. Together, this will determine which light rays are absorbed, reflected, or transmitted. Opaque are the objects that don't transmit any light. Just like a cat. That means all the wavelength of the light are either absorbed or reflected. And if reflected, it will determine the object's color. But in some cases, there might be an object that reflects a range of wavelengths that together combine to give a particular color. Let's imagine the yellow circle as a cheese. It may appear yellow by reflecting the yellow wavelength, or it might appear to be yellow by reflecting red and green wavelength, which is combined to be yellow. Transparent and translucent objects, on the other hand, transmit lots of light that hits them, which means that a path has straight through the transparent object. Like the glass in the windows, they are almost completely see-through because they transmit nearly all of the light with only small fraction being absorbed or reflected. Meanwhile, translucent objects only transmit some of the light, and the proportion of light they transmit determined by which wavelengths are transmitted.
Everyone, my name is Ryder Mirandes from 12 Junes. Let's talk about emission and interference. Emission. In physics, emission is the process by which a higher energy quantum mechanical state of a particle becomes converted to a lower one through the emission of a photon, resulting in the production of light. So, ang emission daw ay ang pagpapalabas ng mga proseso kung saan ang isang mas mataas na enerhiya, kabuuan ng makina ng estado ng isang maliit ay nagko-convert sa mas mababang isa sa pamamagitan ng paglabas ng photon. Nagresulta sa paglabas ng ilaw. The energy state of the transition can lead the emission over a very large range of frequencies. For example, visible light is emitted by the coupling of electronic state in the atoms molecules. Then the phenomenon is called fluorescence or phosphorescence. On the other hand, nuclear shell transition can emit high energy gamma rays, while nuclear spin transition emit lower energy radio wave. Paglipat ng energy state ay pwedeng humantong sa emission. Halimbawa, visible light, phenomenon tinatawag na fluorescent o phosphorescence. Ito yung mga ilaw natin na gumagamit ng mga fluorescent, mga ganun. The emittance of an object quantifies how much light is emitted by it. This may be related to other properties of the object through the Stefan-Boltzmann law. For the most substance, the amount of emission varies with the temperature and spectroscopic composition of the object, leading to the appearance of color, temperature and emission lines. Precise measurements at many wavelengths allow the identification of a substance via emission spectroscopy. Pag sinabi namang emittance, bagay na tumutukoy sa dami ng ilaw na nilalabas nito. 2. Interference. In physics, interference is a phenomenon which two waves superpose to form a resultant wave of greater, lower, or the same amplitude. Constructive and destructive interferences result from the interaction of waves that are correlated or coherent with each other, either because they come from the same source or because they have the same or nearly the same frequency. Interference effects can be observed with all types of waves. For example, light, radio, acoustic, surface, water waves, gravity waves, or matter waves. The resulting image or graphs are called interferogram. Pag sinabi namang interference, the net effect na ng pagsasama-sama ng dalawa o higit pang wave trains na gumagalaw sa magkasalubong o nagkataon ng mga landas. Ang epekto nito ay ang pagdaragdag ng mga amplitude ng mga individual na wave sa bawat puntong naapektuhan ng higit sa isang wave o ilan.
So, hi mga ka-I-Believers! My name is Frenny Lim. So, ang pag-aaral natin ngayon ay tungkol sa atmospheric optics. So, halika na at mag-aral na tayo. Atmospheric optics deal with how the unique optical properties of the Earth atmosphere cause a wide range of specular optical phenomena. The blue color of the sky, a direct result of ray light, higher frequency, sunlight, block into the field of view of the other observed. So guys, kung makikita nyo, di ba? Ang mga ulap is kulay blue dahil yun sa ray light. So next, because of the light blue, yung ray light is scattered more easily than red light. The sun takes on the reddish hue when it is observed though a thick atmosphere as during a sunrise or sunset. So makikita niyo naman guys yung red na sunlight or yung mga sunset, yun yung paglubog ng buwan at yung pagtawag dun yung pagpas tuwing umaga, pagbukang diwaybay ba yun, yung tawag dun. Dun yung makikita yung nag-iiba't iba ko rin nagiging red, minsan nagiging orange, yellow, ganon. Additional particular matter in the sky can scatter different colors and thus creating colorful glowing skies at dusk and dawn. Yung mga yung mga nakikita niyo naman sa mga sky is yung parang mga ilaw, extra color na mga na ilaw. Scattered of ice, crystal, and the other particles in the atmosphere are responsible for holes, afterglows, coronas, ray of sunlight, and sun dogs. The vibration in this kind of phenomena is due to different particular size and geometries.